starting values of 1 and 8. So you can see here, our Q value is going to be 1, our R value is going to be 8. I use a binary tree, and by that I mean I will start with a node, I will give it the value of 1, 8. I will then look to the matrix and I will put the value of P sub 1 sub 8 in here. So that gives me a reference. So I now know that I'm calling path 1, 8, and if path value of P 1, 8 is not equal to 0, which is equal to 9, I will then enter this if statement and I will call path Q P sub Q sub R. So that means is I will now be calling path, but I will be calling it for 1, 9. So I'm in a new recursion here, a new level, a new scope for this. So I will now look at the matrix once again, and I will get the value of 5. So now since I'm in a new call of path, and Q is 1, and R is 9, I'm going to look at if P, Q of R is not equal to 0, which it's equal to 5, I'm going to go back in and recurse once again. So I will call path Q, which is 1, and Q of R, which is 5, and I will end up with the value of 0. So now I've called path 1, 5, and I end up with the if statement that if P of 1 to 5 is not equal to 0, which it is, that eliminates everything that's left in this method. I exit out. I don't recurse. I go back to this recursion. Now in this recursion, I had called path. You can see I called path the first time from here, but I did not call it a second time. So the next thing that I would do is I would hit this print statement. And I'm just going to, for simplicity's sake, I'll just write over here V5, because that's the value of P sub Q sub R. But now I'm not done. I have to go into the second recursion. Now here it's P sub Q sub R and the value of R. So this I'm going to recurse to the right now, letting me know that I'm on my second recursion from this level, and I'm going to give it the value of 5, 9. Now I'm going to look into my matrix and I'm going to see that this has a value of 3. So first thing I'm going to do, once I pass in 5, 9, if P sub 5, 9 is not equal to 0, it isn't, it's equal to 3, I'm going to call path Q, very first recursion of path, and I'm going to go to the left. So the value now is going to be Q and P of Q sub R. So I will now have the value of 5, 3 here. I will look at my value of 5, 3. I see that that's 0. So at path 5, 3, if P of 5, 3 is not equal to 0, well, it is equal to 0. So now I know I do nothing in this. I exit out, I go back to this where I had already called path 5, 3, and now I will do my print statement. I'm printing the value of 3 here, and then I'm going into my second recursion. I will do another right line to signify that second recursion, and here I'm going to have the value of 3, 9. So I'm going to look to 3, 9. I get the value of 0, and I know if I'm calling path 3, 9, if path 3, 9 is not equal to 0, well, it is equal to 0. I don't do any of that. I exit the recursion. But now, when I go here, I can see that I'm on the second call. I've called path once, I've printed it, I've called path twice, I'm done. So now I exit out of this. But now I can see once again, I've called path once within 1, 9, I've printed it, and then I called it twice within 1, 9, and so now I'm done with this. But what that leaves us is we have called within path 1, 8, we are at this first recursion call where we called path 1, 9. So the next thing that we'll do is we'll go down 1, do our print statement. V9, our next step. So this has been done. So now we're going to move on to this second recursion for our very first level. So this one is going to be the value of 9, 8. So it's 9, since we're now, the value of PQR is 9, and the value of R is 8. We're going to look into there. We're going to see that the value is going to be 7. So we have just called path Q of R. We saw that PQ of R was not equal to 0, it's equal to 7. So we're going to call it once on our first recursion. So this one comes down here. I'm going to erase this side because we're done and we will not be going back to that at all. Just making room for myself to write. So at 9, 8, we're going to take a look in here and see what we have. No, I'm sorry. At 9, 8, first thing we do is we call path Q, piece of Q sub R, which is 9, 7. We'll take a peek in 9, 7. We see that we have a value of 6. So once again, the first thing we're going to do when we enter that is we're going to look. 6 is not 0, so we're going to call path 9, 6. And now we're going to look in 9, 6, and we have a value of 0. Cross that off. We come back to this. We've called our first recursion. We're now on to the print statement. V6. Now we're on to our second recursion. I'm going to come down. Our recursion is going to be 6, 7. It's going to have a value of 0. We're not going to do anything for that because if we call path QR on 6, 7, the very first thing, we get a value of 0. We exit out. We've already printed this. We've called the first recursion. We've printed. We called the second recursion. So we're done with this now. So now we're on to the second recursion of, no, I'm sorry. Now we're on, we had called the first recursion. You can see that's all, I signify that by the left-hand pointer. And so now the next thing that we'll do is we'll print. Now on to the second recursion. So we'll be calling 7, 8 here. And the value for 7, 8 is 0. When we pass 7, 8 into path QR, we get the 0 value here. That eliminates that. So we're out of here. So we can see that we've called, on this level, you can see that we've called the left-hand recursion. We've printed and called the right-hand recursion. So we're done here. Now you can also see that we called the left-hand recursion, we printed, and we called the right-hand recursion. And we're done there. The method is done. We're out of the entire method. This is your solution. All you have to do at this point is, since you know that you started at Q, V1, and R, V8, this will be your path starting at 1, 5, 3, 9, 6, 7, 8. That is the Floyd's 2 algorithm for the shortest path done in the binary tree form of recursion.